Today, we're going to learn about the vector data structure, more specifically how to access elements using the front, back, and square bracket operator. Hello, I'm James Helfrich. The vector is just like the array in that we can access elements using the square bracket operator if we have the index. We can also conveniently access the first and last element using the front and back method as well. We'll start with a vector that has 5 elements as well as 3 other variables. Our vector is going to have 5 elements initialized with initializer list, 10, 11, 12, 13, and 14. And we're also going to have 3 other variables which we'll later use. Now we can access the first element of the vector using the front method. And this is going to set 0 to 10 because that's the slot at element 0. We can also access the back element using the back method. And this will, in this case, initialize the variable 4. And we can also access an element in the middle using a square bracket operator. Now, when we use a square bracket operator, no error checking is done. In other words, we're assuming the client is going to provide us the correct index. We can use the @ method as well, which will do some error checking and throw an exception if the wrong value index is passed. Now, a lot of people don't know that we can actually change the front element of the vector with the front method, and we can change the back element with the back method, and we can, of course, change an element in the middle using the square bracket operator. In other words, both a read-only and read-write version of all 3 of these methods are provided. The vector provides several access methods. The square bracket operator, which is both the read-write version and the read-only version. The @ method, which is the same as the square bracket, except it also throws an exception. And we have the front and back method, both the read-only, the read-write, and the read-only version of each of these. We can learn more about how these are implemented by looking at the implementation section of the C++ data structures textbook. Each one of these access operators is accessible in O sub 1, in other words, constant time. And because we're using an array as the underlying data structure, we simply need to take the past index and send it to our data memory variable and return the appropriate value. And add is the same thing, except we'll throw an exception if we're outside of range. Front always returns array of 0, and back always returns array of num elements -1. If you would like to learn more about the vector data structure, or any other data structure for that matter, take a look at the C++ data structures textbook. A link is provided in the description below.